Good morning, everyone. I am Dr. G. Seshadri, working as a professor in Institute of Aeronautical Engineering. Today, I want to discuss about some DC generator numerical problems in course objectives. The students will try to learn the elementary, experimental, and modeling skills for handling problems with electrical machines in the industries and domestic and industries and domestic applications to excel in professional career. The operation of DC machines and its role in power transmission and distribution, the intuitive knowledge needed to test and analyze the performance leading to design of electrical machines by conducting various tests and calculate the performance parameters. Coming to the course outcomes, at the end of the course, the students should be able to analyze the performance characteristics of DC machine under various loading conditions, determine the electrical critical field resistance and speed of DC generator using circuit characteristics, examine the performance of DC machine with different speed control techniques and predetermine the efficiency, estimate and separate the core losses in DC machine by conducting a suitable test, examine the performance and speed control of DC machines using simulation tools. First one, we will discuss regarding numericals. First one, the brushes of a certain lab connected 400 kilowatt 6 pole generator is given a lead of 18 degrees electrical. Need to calculate first one, the demagnetizing ampere turns. Second one, the cross magnetizing ampere turns. Third one, series turns required to balance the demagnetizing component. The full load current is 750 amps. The total number of conductors are 900 and the leakage coefficient is 1.4. So coming to the solution, so we will analyze the given data. In given data, the generator rating is 400 kilowatt, power is 400 kilowatt, voltage 400 volts, given number of poles are 6 and lab connected. That means we are having power equal to 400 kilowatt, voltage is given as 400 volts and number of poles P equal to output power and P equal to 6 and it is lab connected means here it is A equal to P and given number of conductors as 900 and full load current is given as I equal to 750 amps and theta E equal to 18 degrees. Leakage coefficient is 1.4. For lap winding we know A equal to 6, so the electrical angle is related to mechanical angle as P by 2 into 2 theta E, that is mechanical equal to P by 2 means number of poles are 6 into 2 and mechanical degrees as 18, P by 2 into theta E 18. So the electrical angle related to mechanical angle is 6 degrees and ampere turns per pole is given as IZ by 2AP. Here I is given as current is 750, Z 900, number of parallel paths 6 and P is also 6. So after substituting this IZ into IZ by 2AP, we'll get a 9375 ampere turns per pole. These are the total ampere turns per pole. And coming to the demagnetizing ampere turns, the formula is theta E by 180 into 2 into ampere turns per pole. So already calculated theta E as 18 and 180 2 into ampere turns per pole 9375. So this will use 1875 ampere turns per pole, 1875 ampere turns per pole. So after deducting this demagnetizing ampere turns 1875 from 9375, we'll get 7000 ampere turns per pole. So these are nothing but cross magnetizing ampere turns per pole, ATC per pole. So to balance the demagnetizing effect, the required series field turns per pole are ampere turns per ampere. So it is 1875 divided by 750, which is approximately 3 turns per pole. So it is not possible to 2.5 turns per pole. So it is taken as 3 turns per pole. And the leakage coefficient is only used when finding total excitation. So now it is not required. So it does not affect these values. So we have final answers as demagnetizing ampere turns per pole are 1875 and cross magnetizing ampere turns per pole are 7500 and series turns required are 3 turns per pole. So this is the problem related to the ampere turns per pole. Second problem. Calculate the reactance voltage for a machine having the following particulars. The particulars are number of commutator segments are 55, revolutions per minute are 900, brush width in commutation segments is 1.74. Also, coefficient of self-inductance is given as 153 into 10 power minus 6 henries. And current per coil is given as 27 amps. So given data is number of segments are 55, speed is 900 rpm, brush width is 1.74 segments, and coefficient of self-inductance is nothing but 153 into 10 power minus 6 henries, that is L. And current per coil is given as 27. First, the time for one revolution will calculate. So given revolutions per minute are 900. So we can calculate the time for one revolution as 600 by 900. It is 0.06677 seconds. Hence, the time per commutation segment is, we have total commutator segments are 55. So the time per commutation segments per commutation segment is, we will divide this 0.0667 seconds with 55, we will get 0.001212 seconds. And during the commutation, the brush short circuits at 174 segments. So the time of commutation denoted as TC is 1.74 segments into time per commutation. So time per commutation already we have calculated that 0.001212 seconds. So finally we will get the time per commutation as 0.00211 seconds. And also the reactance voltage, which is nothing but commutation EMF, is already given in the formula, that is reactance that is given by E equal to 2Li by time of commutation. So we need to substitute all these values. E equal to 2 into L is given as 153 into 10 power minus 6 and this is L, and I is 27 and time commutation is 0.00211 seconds. So after substituting all these values, we have the reactance voltage as 3.92 volts. So therefore the reactance voltage is calculated as 3.92 volts and this is the final answer. And we will see one more problem related to the parallel operation of DC shunt generators. Here, two shunt wound generators running in parallel have each an armature resistance of 0.02 ohms and field resistance of 50 ohms. The combined external load current is 5000 amps and the fields are excited so that the EMF induced in one machine is 600 volts and in the second machine is 610 volts. Calculate the busbar voltage and the output of each machine. So we need to calculate the busbar voltage. Here busbar is nothing but it is a thick copper conductor which is used to parallel operation of two DC machines. So positive terminal of busbar is given to the positive side of armature one and the negative terminal of busbar is given to the negative side of armature. So here given two shunt generators running in parallel. So each having armature resistance as 0.02 ohms and field resistance, shunt field resistance is RSH or RF equal to 50 ohms. And the total current is 5000 amps given and induced EMF E1 is as 600 volts and E2 is 600 volts. So let us assume that the busbar voltage is V and the respective armature currents also I1 and I2. So already we have the external load current, combined external load current as 5000 amps. Here combined external load current means I1 plus I2, current of both the machines I1 and I2 as 5000 amps. For each machine we have E1 600 volts and E2 600 volts. So we will calculate I1 and I2 and also E1 as V equal to I1 into RA and E2 equal to V plus I2 into RA. By substituting these values and subtracting these two expressions 1 and 2, E2 minus E1 equal to I2 minus I1 into RA. E2 minus E1, since E2 is 610 and E1 is 600, so difference is 10. 10 volts equal to I2 minus I1, we don't know, and into RA, we have RA value. So from this I2 minus I1 becomes 500 amps. Also given I1 plus I2 as 5000 amps. So I1 plus I2 equal to 5000 amps. We have I1 minus I2 equal to 500 amps. So 2I1 equal to 5500 amps. I1 equal to 5500 by 2, which is nothing but 2250 amps. So if I1 equal to 2250 amps, easily we can calculate remaining I2 value as 2750 amps. And now we can calculate the busbar voltage by substituting I1 value or I2 value. So busbar voltage, we will substitute first I1 value to find out the busbar voltage. So we have already E1 value as 600 and I1 just now calculated as 2250 amps and RA already we have 0.02 amps. After substituting all these values, we have V as 555 volts and also we can check with the second machine also just by simply substituting instead of I1 I1 we are substituting I2. So we have I2 as VTE2 as 610 and I2 we have just now calculated as 2750 amps and RA 0.02. We have cross verified this busbar voltage with the second machine also. So the voltage of busbar is 555 volts. So now we can calculate the output of generator 1. So we have V, which is 555 volts, and I1 2250. So output of generator 1 is 1248.75 kilowatt, and we can calculate remaining generator 2 output also, V into I2, which is 1526.25 kilowatt. So final answers, we have calculated bus bar voltage 55 volt, generator 1 output as 1248.75 kilowatt, and generator 2 output as 1526.25 kilowatt. And we will see simple problem related to the DC machine. A 10 kilowatt 250 volts DC 6-pole shunt generator runs at 1000 rpm when delivering at full load. The armature has 534 lap connected conductors, and full load copper loss is 0.64 kilowatt, and the total brush drop is given as 2 volts. Determine the flux per pole, neglect shunt current. So given, so we will come into the solution. First we will analyze the given data. Since a shunt current is negligible here, there are no shunt field copper losses. So only armature copper losses occurs in armature only. There is no field copper loss. And also I equal to given already, I equal to given as 10 kilowatt by voltage IA equal to 40 amps. And armature losses I square RA we don't have, so we can calculate RA value as 0.4 volts. And IARE equal to 16 volts. And brush contact voltage drop per brush is given as 1 volt, so total brush voltage drop is 2 volts. And we can calculate generated EMF is equal to V plus IARE. So here IARE is EG equal to V plus IARE plus brush contact voltage drop. So here V equal to 250 volts given, and IARE 16 volts we have calculated. Brush current drop already given as 2. So total 268 volts is EG. And we know generalized formula for EG equal to 5/16 to P by A. So from this, after substituting all the numericals, we can calculate the phi as 30 milliamperes. So these are about some numerical problems related to the DC generators. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.